Hello, everyone. My name is Ryosuke Yamamoto from Japan. I'm a system software researcher at the Mitsubishi Electric Corporation. Today, I will talk about real-time operating system execution strategies on virtual machine in RISC-V architecture. I have researched about the virtualization in RISC-V architecture, and I discovered the issue that some RTOS can run on virtual machine in RISC-V architecture. So I invited a method that can run RTOS on virtual machine in RISC-V architecture. So today I'll talk about background and issues, and then I will explain our proposed method. And finally, I will talk about future works. First of all, trends in the embedded industry. Recently, attention has been focused on RISC-V architecture. RISC-V architecture has great features, such as open and extensible. Those features are suitable for embedded systems. And now we focus on this topic. Google announced RISC-V support for Android. The use of RISC-V in smartphones will increase awareness of RISC-V's performance. And on the other hand, there are demands for complex mixed OS environments. One of the demands is strong isolation. For example, the coexistence of real-time and information processing. And another one is ensure safety and security. And another demand is adding or removing operating systems dynamically. So for those reasons, we expect complex mixed OS environments is required in RISC-V architecture. So our goal is realization of complex mixed OS environments in RISC-V architecture. So how to realize mixed OS environments? There are two major ways. First, logical partitioning. This is a simple method. It splits hardware resources per guest operating systems. But this method requires modification to guest operating systems, so it may need more money, more developers for develop each product. At second, virtualization. Virtualization runs operating systems on the virtual machines, so it may be able to operate without modification to the operating systems. So today, in this presentation, we target virtualization because virtualization is more suitable for complex mixed OS environments rather than logical partitioning. However, virtualization needs hardware support. RISC-V architecture supports virtualization by using hypervisor extension. Hypervisor extension is already available as version 1.0. So I'll explain about hypervisor extension simply. So this slide shows a privilege mode configuration. So left figure shows privilege mode without hypervisor extension. From bottom, machine mode, supervisor mode, and user mode. And each mode runs firmware, operating systems, and application. And M mode is the highest privilege level, and the U mode is lowest. And the right figure shows privilege mode with hypervisor extension. HS mode is added for hypervisor, so hypervisor can run on VS mode, and hypervisor can manage VS mode and the VU mode. VS mode is virtual supervisor mode, and VU mode is virtual user mode. So, and VS mode and the S mode has same interface. So, operating system running on S mode can run on VS mode. So then I discovered an issue. that some operating systems such as RTOS running M-mode. So hypervisor cannot cannot control RTOS because some RTOS cannot run on S mode or VS mode. Why some RTOS cannot run S mode or VS mode? I consider 2 reasons. First, a RISC-V processor may not implement S mode like a microcontroller for tiny systems. And second, the more authoritative software interfere with real-time processing. So for those reasons, I think RTOS running on M mode is common. So what will happen if we force RTOS to run in VS mode? RTOS often does not work properly due to M-mode specific operation. M-mode specific operation occur exception, and M-mode specific operation can be classified into 4 types. First, instruction. For example, emulate instruction. Emulate instruction is used return from M-mode exception handler or interruption handler. And emulate instruction can be executed only in M mode. Second, registers, CSRs. For example, M status, MIE, and M codes. Also, those registers can be executed only in M mode. And third, exceptions and interrupts. Some interrupts and exceptions depend on privilege mode. For example, environment call from M mode and machine mode timer interpret. And finally, memory and I/O. This is a little bit special case. Sometimes firmware restrict specific address space. So RTOS running on VS mode cannot access restricted address space. Okay, then so we proposed a method that virtualize M-mode specific operation and run RTOS. M-mode specific operations occur exception, and then hypervisor or hardware hook this exception and virtualize. So our proposed method virtualize 4 types of M-mode specific operations like that. First, simulate instruction. Second, provide virtual registers, virtual CSRs. And third, replace exception of the interprets. And finally, provide virtual memory and I/O. Okay, for now, we implement proposed method only with the hypervisor because confirmation of feasibility and extract processes that require virtualization. Of course, we expected virtualization overhead, delay, real-time processing in RTOS. So I will talk about in this topic later as future works. So verification. So we verify our proposed method. So we run a free RTOS sample application following that. And this application generates 2 tasks, and tasks communicate with each other using message queue. And now we implemented a part of proposed method in Violet hypervisor. Violet is a hypervisor for RISC-V architecture, and Violet makes it easy to add extension like the proposed method. Actually, Violet is developed privately by myself. So you can access following URL or QR code. And so if you're interested in our proposed method or hypervisor, you can see source code and you can try our proposed method. Okay. So I'll show you the demonstration. Okay. Yep. So this is in Virtualization hypervisor project. So and run QM and OpenSDI hypervisor and the FreeRTOS application. This message shows applications. And now a hypervisor can stop virtual machine and restart virtual machine. So you can see hypervisor can manage virtual machine and FreeRTOS because FreeRTOS run on VS mode, right? Oh, sorry. Okay, and future works. So as I said before, when M-mode specific operation executed, and then exception is occurred. And then hypervisor run for virtualization. So in this point, the overhead is incurred. So current proposed method has overhead when M-mode specific operation is executed. So this is a severe problem. So we are considering new hardware extension. New hardware extension as a new privilege mode and run operating systems. So as I said before, operating system running on S mode can run on VS mode because S mode and VS mode have the same interface. So in the same way, new hardware extension as a new privilege mode like VM mode, virtual machine mode. So this new privilege mode has same interface as M mode, machine mode. By doing so, RTOS can run on this new privilege mode. So using this new extension, so we can run RTOS on virtual machine without virtualization overhead, without modification. So this is summary. In RISC-V architecture, complex mixed OS environments will be required, and when implementing the mixed OS environment, OS environments through virtualization, it is difficult to run RTOS with existing hypervisor extension. In the proposed method, the RTOS is run on the virtual machine, and the M-mode specific operation of the RTOS are virtualized. As a result of operation verification with FreeRTOS, we were able to confirm to the feasibility of the sample application that runs on a virtual machine. In the future, consider hardware offloading of virtualization processing. And finally, this is an important slide. So in practical use of the proposed method, the realization of hardware extension is essential. So we are going to develop a new extension of FPGA. So if you want to collaborate or comment, please contact me later. And I want to contribute to the RISC-V community regardless of this topic. And if you are interested, please feel free to contact me. And this is contact information. Thank you for listening. That's it.
Hi, I'm James Ball from Qualcomm. So to add the VM mode, did you have to go through and make lots more like VM mode versions of the CSRs? Because there's all the M mode CSRs. Can you hear me okay? Yeah. A little bit? Yeah. Try again. So there's a lot of CSRs you have to add for VM mode probably, right? So then you had like M status, now you have VM status.
Yeah.
So you did kind of like what was done with the hypervisor to create VS mode, right? So, okay, I just wanted to know if that was the approach you took, if you did some other thing. But that's what you did, right? You added like VM mode registers, CSRs.
Yeah.
Okay.
Yeah. So, yes. Did you say about this, like this?
Oh, yeah. Okay. I didn't see the bottom right-hand corner. When
Yeah.
Yeah. Thank you. That's what I'm asking about. Yeah.
Yeah,
Thanks.
yeah.
Hello.
Hello.
Don't you think this approach will impact a lot on the latency and the worst-case execution time that you need for real-time operating systems?
This is in hardware extension or only hypervisor?
But you need to trap all the time. And while you are trapping, you may receive an interrupt, and this interrupt will be stuck while you are still serving the trap for the DS mode. I think this will impact a lot the latency that you need on real-time operating systems.
Yes, yes, you're right. And so only virtualization only with a hypervisor. Yes, you're right. Overhead is a lot because of virtualization of CSRs. For example, when RTOS interrupt is occurred in RTOS, in interrupt handler, RTOS access to some registers, M status, MIE, M codes. So at least 3 times of virtualization needed. But so we proposed hardware extension like that. So using this hardware extension, so those registers access is not need hypervisor virtualization. So our RTOS can access to physical registers, so like VM mode, VM status, or VMIE, etc. So using this new extension, so it's not a problem, I think.
Yeah, just to follow up, so I think the whole point of what you're saying of the hardware extension is that you don't have to be trapping all the time on MRET or trying to access like M status. Because, okay. Do you have a follow-up question? Do you want the mic? Yeah. No? Okay.
Okay.
Hi. What else do you imagine is running in other containers in the virtual world? Have you got more than one RTOS in your use case? Why have you virtualized it at this point?
Sorry, I can't listen. Please.
What's the use case? What other things are running virtualized at this point? Have you got multiple RTOSs running? What's your use case here? Why have you put the RTOS in VS mode in the first place? I assume it's to have multiple RTOSs running in virtualized environments, right?
Okay. Did you see multiple RTOS in single core, right? Multiple operating system, multiple RTOS in single core. No.
It's a question. I mean, is that your use? Is that the use case scenario that you're?
Use case. So I think about like that. Some products mixed real-time and information processing, like free RTOS and Linux. So, and those cases are split processor core, and single core is run on RTOS, and another core running information processing, like Linux.
All right, I'm afraid we're out of time.
Okay. Okay. Thank you very much.